Hi, this is Javin Kharod, a production chemical engineer by profession, going to continue our today's topic, continuous distillation. Now, continuous distillation, a form of distillation, is an ongoing separation in which a mixture is continuously, without interruption, fed into the process and separated fraction. They are removed continuously as output stream. Distillation is the separation or partial separation of a liquid feed mixture into component or fraction by selecting boiling or evaporation and condensation. The process produces at least two output fraction. This fraction includes at least one volatile distillate fraction which has boiled and been separate, captured as a vapor condensed to a liquid, and practically always a bottom or residue fraction, which is the least volatile residue that has not been separately captured as condensed vapor. An alternative to continuous distillation is batch distillation, where the mixture is added to unit at the start of distillation. Distilled fraction they are taken out subsequently in time during the distillation, and the remaining bottom fraction is removed at the end because each of the distilled fraction they are taken out the different time. Only one distilled exit point is needed for a batch distillation, and the distillate can just be switched to a different reservoir. A fraction collecting container batch distillation is often used when smaller quantity they are distilled in a continuous distillation. Each of the fraction stream is taken simultaneously throughout operation. Therefore, separate exit point is needed for each fraction. In practice, when there are the multiple distillate fractions, the distilled exit point they are located at different height on a fractionating column. The bottom fraction can be taken from the bottom of distillation column or unit, but is often taken from a reboiler connect to the bottom of the column. Each fraction may contain one or more component type of chemical compound. When distilled crude oil or a similar feedstock, each fraction contains many components of similar volatility and other property. Although it is possible to run a small scale or laboratory continuous distillation, most often continuous distillation is used in large scale industrial process. Distillation is one of the unit operation of chemical engineering. Continuous distillation is used widely the chemical process industries where large quantity the liquid have to be distilled. Such industries are natural gas processing, petrochemical production, coal tar processing, liquid production, liquefied air separation, and hydrocarbon solvent production. Cannot be separation and similar industries, but it finds widest application the petroleum refinery. In such refinery, the crude oil feedstock is a very complex multi-component mixture that must be separate and yield a pure chemical compound. They are not expected only the group of compound with a relative small range of boiling point, which are called fraction. These fractions are the origin of the term fractional distillation or fractionation. It is often not worthwhile separating component in this fraction any further based on product requirement and economy. Industrial distillation is typically performed in large vertical cylindrical column known as distillation tower or distillation column with diameter ranging from about 65 cm to 11 meter and height ranging from about 6 meter to 60 meter or more. The principle for continuous distillation is the same as for normal distillation. When a liquid mixture is heated so that it boils, the composition of the vapor above the liquid different from the liquid composition. If the vapor is then separated and condensed into liquid, it becomes richer, the lower boiling point component of the original mixture. This is what happens the continuous distillation column a mixture is heated up and routed into distillation column. On the entering the column, the feed starts flowing down, but part of it, the component with lower boiling point, vaporizes and rises. However, as it rises, it cools, and while part of it continue up the vapor, some of it enriched less volatile component begin to descend again. Now, move further. In simple, continuous fractional distillation tower, for separating feed stream into two fractions, an overhead distilled product and a bottom product, the lightest product, those with the lowest boiling point of highest volatility, exit from the top of the column, and heaviest product, the bottom, those with highest boiling point, exit from the bottom of column. The overhead stream may be cooled and condensed using a water cooler, air cooler, condenser. The bottom reboiler may be steam heated or hot oil heated heat exchanger or even a gas or oil fired furnace. In a continuous distillation, the system is kept in a steady state or approximate steady state. Steady state means that quantity related the process do not change as time passes during operation. Such constant quantity include feed input rate, output stream rate, heating, cooling rate, reflux ratio, and temperature, pressure, and composition at every point, unless the process is disturbed due to changing feed heating ambient temperature or condensing. Steady state is normally maintained. This is also main attraction, the continuous distillation, apart from minimum amount of easily instrumentable survivalence. If the feed rate and feed composition are kept constant, product rate and quality they are also constant even when a variation in condition occur. Modern process control method they are commonly able to gradually return the continuous process to another steady state again. Since the continuous distillation unit is fed constantly with the feed mixture and not filled all the once like a batch distillation, a continuous distillation unit does not need sizable distillation pot, vessel or reservoir for a batch fill. Instead, the mixture can be fed directly into column where the actual separation occurs. The height of the feed point along the column can vary on situation and is designed so as to provide optimum result. The continuous distillation is often the fractional distillation and can be vacuum distillation or steam distillation. Now, its design and operations. Design and operation, the distillation column depend on feed and desired product. Give an example, the binary component feed analytical method such as the McCabe-Thiele method or the Frank-Scott equation can be used to assist the design for a multi-component feed computerized simulation model. They are used both the design and subsequently operation of the column as well. Modeling is also used to optimize already erected column for the distillation mixture other than those the distillation equipment was originally designed for. When a continuous distillation column is in operation, it has to be closely monitored changes in feed composition, operating temperature, and product composition. Many of these tasks are performed using advanced computer control equipment. Now, column feed. The column can be fed in different way if the feed is formed. Sources a pressure higher than the distillation column pressure. It is simply piped into column. Otherwise, feed is pumped or compressed into column. The feed may be superheated vapor, a saturated vapor, a partially vaporized liquid vapor mixture, a saturated liquid at its boiling point, the column pressure, or subcooled liquid. If the feed is liquid at a much higher pressure than the column, the pressure and flow through a pressure let down valve just ahead of the column. It will immediately expand and undergo partial flash vaporization, resulting in a liquid vapor mixture as it enters the distillation column. Now, for improving separations. Also, small size unit, mostly made glass, can be used. Laboratory, industrial unit, they are large vertical steel vessel as distillation tower or distillation column. To improve the separation, the tower is normally provided inside the horizontal plate or tray. The column is packed with a packing material to provide the heat required for a vaporization, involve the distillation and also compensate for a heat loss. Heat is most often at bottom of the column by reboiler. The purity top product can be improved by recycling some of the externally condensed top product liquid as reflux depending on their purpose. Now reflux. Large scale industrial fractionation tower are reflux to achieve more efficient separation of product. Reflux refer the portion of condensed overhead liquid product from a distillation tower that is returned the upper part of the tower. Inside the tower, the downflowing reflux liquid provide cooling and partial condensation of the upflowing vapor, thereby increasing the efficiency of the distillation tower. The more reflux that is provided, the better is the tower separation of the lower boiling from the higher boiling component of the feed. A balance of heating with a reboiler at the bottom of a column, the cooling by condensed reflux at the top of the column, maintain a temperature gradient or gradual temperature differences along the height of the column to provide good condition for fractionating the feed mixture reflux flow at the middle of the tower. They are called pump around. Now changing the reflux in combination with changes in feed and product withdrawal can also be used to improve separation property of a continuous distillation column while in operation. In contrast to adding plate or tray, the changing the packing which would be minimum require quite significant downtime. Distillation tower used various vapor and liquid contacting method to provide the required number of equilibrium stages. Such as device are commonly known as plate or tray. Each of the plate or tray is at a different temperature and pressure. The stage at tower bottom has highest pressure and temperature. Progressing upward in the tower, the pressure and temperature decreases for each succeeding stage. The vapor liquid equilibrium for each feed component in the tower react in its unique way to the different pressure and temperature condition at each of the stage. That means that each component establishes a different concentration in the vapor and liquid phase at each of the stage, and this result in the separation of the component. Some of the example tray are depicted. They are more detailed expand image. The two tray can be seen. Each physical tray or plate were 100% efficient, then the number the physical tray needed for a given separation would equal number the equilibrium stage the theoretical plate. However, that is very seldom the case, hence the distillation column need more plate than the required number the theoretical vapor liquid equilibrium stages. Now we are talking about its packing. Another way the improved separation the distillation column is used a packing material instead of tray. This often advantage lower pressure drop across the column where compare the plate or tray beneficial when operating under vacuum. If a distillation tower use packing instead of tray, the number of necessary theoretical equilibrium stage is first determined and then the packing height equivalent the theoretical equilibrium stage known as height equivalent theoretical plate is also determined. The total packing height required is the number of theoretical stage multiplied by height equivalent theoretical plate. This packing material can either be random dump packing such as rusting ring or structure sheet metal. Liquid tend to wet the surface of the packing and the vapor pass across the wetted surface where mass transfer take place. Unlike conventional tray, the distillation in which every tray represents a separate point of vapor liquid equilibrium. The vapor liquid equilibrium curve in a packed column is continuous. However, when modeling packed column, it is useful to compute a number of theoretical plates to deonate the separation efficiency of the packed column with respect to more traditional tray. Different shape packing have different surface area and void space between packing. Both of the factors affect packing performance. Now, another factor, in addition to packing shape and surface area that affect the performance of random or structure packing, is liquid and vapor distribution entering the packed bed. The number of theoretical stages required to make a different separation is calculated using a specific vapor to a liquid ratio. If the liquid and vapor are not evenly distributed across the superficial tower area as it enters the packed bed, the liquid to vapor ratio will not be corrected in a packed bed and the required separation will not achieve. The packing will appear to not be working properly. The height equivalent to a theoretical plate will be greater than expected. The problem is not packing itself but maldistribution of fluid entering the packed bed. Liquid maldistribution is more frequently the problem than vapor. The design of liquid distributor used to introduce feed and reflux to a packed bed is critical to making a packing perform a maximum efficiency. Method of evaluating the effectiveness of a liquid distributor can be found in reference. Now, multi-component distributions. Besides fractional distillation, that is mainly used for crude oil refining, multi-component mixture are usually proceed in order to purify their single component by means series distillation column. The distillation train. A distillation train is defined a sequence distillation column arranged in series or parallel whose aim the multi-component mixture purification. Now, we are talking about process intensifying alternative. The dividing wall column unit is most process intensifying unit related to distillation, continuous distillation of crude oil. Petroleum crude oil contain hundreds of different hydrocarbon compounds, paraffin, naphthalene, and aromatic, as well as organic sulfur compound, organic nitrogen compound, and some oxygen contain hydrocarbon such as phenol. Also, crude oil generally do not contain olefin. They are formed in many of the processes used in petroleum refinery. The crude oil fractionator does not produce product having the single boiling point, rather it produces fractional having a boiling ranges. For example, the crude oil fractionator produces overhead fraction called naphtha, which becomes a gasoline component after it is further proceed through a catalytic hydrodesulfurizer to remove sulfur and catalytic reformer to reform its hydrocarbon molecule into more complex molecule with higher octane rating value. The naphtha cut as fraction is called contain many different hydrocarbon compounds. Therefore, initial boiling point 35 degrees centigrade and final boiling point 200 degrees centigrade. Each cut produces in a fractional column has a different boiling range. At some distance below the overhead, the next cut is withdrawn from the side of column and is usually jet fuel cut, also known kerosene cut. The boiling range of the cut is from initial boiling point of about 150 degrees centigrade and final boiling point 270 degrees centigrade. It is also contain many different hydrocarbons. The next cut further down the tower diesel oil cut with boiling range from about 180 degrees centigrade to 350 degrees centigrade. The boiling ranges between any cut, the next cut overlap because of distillation separation. They are not perfectly sharp. After this comes the heavy fuel oil cut and finally the bottom product with very wide boiling range. All the cuts are proceed further in subsequent refining. A typical application for distilling in butane hash oil, salt part distillation, the popular method due to salt residence time which allow for minimum thermal stress to the concentrate. In other distillation methods such as circulation, falling film and column distillation, The concentrate would be damage prone to long residence time and high temperature that must be applied. Okay guys, this is up to continuous distillation. I hope you get sufficient knowledge after watching this video. Still then, goodbye. Take care.